Exercise 10.2. Find the number of different arrangement of 4 people sitting in a row on a bench. So for the 1a here, it is 4 factorial. So we have the 4 factorial here, and it is 24. And then B, 7 different book in on a shelf, then it will be 7 factorial. So we have the 7 factorial here, then it is 5040. And number 2, A, find the number of different arrangement of letter in each of the following word. So tiger, n equal to 5. So this will be the 5 factorial 120. B, Olympic 2, 4, 6, 8. So this one is 8 factorial. Then we have the 8 factorial here. Then it is 40320. And the C, we have this one, Paint Blast 2, 4, 6, 8, 10. So we have the 10 factorial. So this will be the 10 factorial. Uh, so it is 362880. Okay. And then question number 3, find the number of different 4 digits that can be formed using 3, 5, 7, 8 without repetition. So we have 4 factorial here, that is 24. And then how many 4-digit number are even? So even, that means it is n with 8 only. So one possible here. Then we have 3 number left here. So this will be 6. I can also say that it is 3 factorial times 1. So it is 6. And then greater than 8,000. So number 2, greater than 8,000, then it must start with 8. Then only it will greater than 8,000. Then we have 3, 2, 1 after we use the 8 here. So we can use the 3, 5, 7 here. Okay. So this one will be 6. Or I can do it this way. That is 1 times 3 factorial 6. Number 4, a child holds 7 different books. 4 of the books are cookery book and 3 of the books are history book. Find the number of ways the book can be arranged if there are no restriction. So A, this one we have 7 factorial. So 7 factorial is 5040. And then B, find the number of ways the book can be arranged if the 4 cookery books are kept together. So we imagine we have the C1, C2, C3, C4 group as one. And then we have the H1, H2, H3, 2, 3, 4. So over here, it is 4 factorial. Multiply with the history book itself. Okay, inside the cookery book is 4 factorial. So we have the 1, 2, 3, 4, 1, 2, 4, 3, and 1, 3, 2, 4, and 1, 3, 4, 2, something like that. Okay, so it's 4 factorial inside the cookery book here. So it will be 4 factorial multiplied with the 4 factorial. So it is 5, 7, 6. Okay. 5-digit number are to be formed using the digit 2, 3, 4, 5, 6. Each digit may be used only once in any number. Find how many different 5-digit number can be formed. So it will be 5 factorial 120. How many of these 5-digit number are even? So even number, then we can end with 2, 4, 6, then it is even. It is end with 3 or 5, then it is odd. So 3 here. Then we have the 4, 3, 2, 1. So after we use one of these 2, 4, 6 in the ending here, then over here we have 4 choice. So this one will be 6 times 12, then it is 72. Okay, I can also do it this way, 4 factorial multiplied with 3. So we have the 4 factorial multiplied with 3, then it is 72. And C, we want to have a number greater than 40,000. So greater than 40,000, it can start with 4 or 5 or 6. So 3, 4, 3, 2, 1. So it is 72. So I can also say it is 3 times 4 factorial. Then it is 72. And D, even and greater than 40,000. Even and greater than 40,000, then we can start with the 4 and then start with 5 and start with 6. Then if I start with 4, then I can only end with 2 or 6. If I start with 5, then I can end with 2, 4, 6. If I start with 6, then I can end with 2, 4. So we have 3 cases here. So that we end with start with 5, 4, start with 5 and start with 6, then all of this will be greater than 4,000. So 1, 1, 1. This is 2, 2, 3 here. Then middle here will be, after we use 2, we left 3. Okay. So this is actually 3 factorial. 3 factorial. So we have the 3 factorial times 2. So the 3 factorial times 2 is 12. So this is 12. This is 12. And I can also 3 factorial times 3. This is 18. So the D here, it will be the 12 plus 18 plus 12. Then it is 42. Okay. So for the C here, okay, we start with 4, 5, 6. So let's say I start with 4 here. So let's say I start with 4 here. So we have 3 choices. If I start with 6 here, okay, if the first digit I use 6, then behind I can use the 5, 4, 3, 2. That is the 4 factorial. Okay, so after we start with 6, then we have the 4 factorial. And I also can have the start with 5 and then we have the 4 factorial. We start with 4, then we have the 4 factorial here. Okay, so we have the 3 times 4 factorial. So this one is the 4 factorial. So it is 3 times 4 factorial. So for the B here, I can end with 2. Then in front, I have 4 factorial. I can also end with 4. In front, we have the 4 factorial. I can also end with 6. Then in front, I have the 4 factorial. So over here, this is the 4 factorial. And we have 3 ending. So we have the 4 factorial times 3 here. Okay. For D here, so this is the first method. So I start with the with uh the number begin. So if I start with the 2 and then 4 and 6, I have 3 cases. So I end with 2, then I can have the 4, 5, 6 to begin. Then I end with 4, then I can only put 5, 6 here. I end with 6, then I can put 4, 5 here. So over here, this is 1, this is 3, this is the 3 times 2 times 1. So we have the 18 here. So the 3 times 2 times 1 is actually 3 factorial. This is 1, this is 2. Then we have the 12 here. Then this is 3 factorial. Then 1, 2, also 12. So the total will be 18 plus 12 plus 12. Then it is the 42. Okay, so I can case 1, case 2, case 3, start with 4, start with 5, start with 6, start with 4, can end with 2, 6, start with 5, can end with 2, 4, 6, start with 6, then end with 2, 4, then one choice, two choice, one choice, three choice, one choice, two choice, and in the middle is 3 factorial. I can also start with the ending with 2, 4, 6, it is even. Then start with 4, then end with 2, then it can start with 4, 5, 6, so that it is greater than 4000 and it is even. So 3 choice, 1 choice, and then 3 factorial. Okay, and then we end with 4, then we can start with 5, 6. And with 6, we can start with 4, 5. So 2 times 3 factorial times 1, 2 times 3 factorial times 1. And then we add up will be the total.